So welcome to this class. In this session, we are going to show that curl of gradient of a scalar function phi is a zero vector. So this is what I'm saying. So show that curl of gradient is a zero vector. So this is curl grad phi is zero vector. That's what you know. So the proof of this one comes from definition of both the gradient and then the curl of a vector, the gradient of a scalar function and curl of a vector. So proof, we know that gradient of phi is given by partial phi partial xi plus partial phi partial yj this from definition. So then to define the curl of this gradient, so curl of gradient of phi will be the same as partial xi plus partial yj plus partial zk, and then we close with partial phi partial xi plus partial phi partial yj plus partial phi partial zk. And then by definition, curl is given in terms of in terms of determinant. This is the determinant of I, j, k partial x partial y partial z, and then partial phi partial x partial phi partial y partial phi partial z. This is by definition of curl. So the next thing is now to evaluate this determinant, knowing that this one has a positive sign, negative sign, positive sign. So we'll have this equals to I, determinant, delete I row, I column. So partial y, partial z, partial phi, partial y, partial phi, partial z, minus j. So delete this, so we'll have partial x, partial z, partial phi, partial x, partial phi, partial z, plus k, determinant of the matrix obtained by deleting the row k, column of k. So partial x, partial y, partial phi partial x, partial phi partial y. And the next step now, let's evaluate those determinants. So we'll have I into, so partial y, you apply it to partial phi partial z minus partial z. So this you apply to this partial phi partial y minus j. You apply this to this, so partial x into partial phi partial z minus partial z into partial phi partial x, and then plus k partial y partial phi partial x minus partial x partial phi partial y, partial phi partial x, not partial y. So this partial x, actually I've reversed here. This should have been partial x, this y, and then this is x, this y. So here we have this one here, partial x. You apply it to partial phi partial y. Then partial y, you apply it to partial phi partial x. So that's the next step. And then let's evaluate these brackets. So curl of grad of phi will be I. Now this will be partial squared phi partial y partial z minus partial squared phi partial z partial y. This is minus j partial squared phi partial x partial z minus partial squared phi partial z partial x plus k partial squared phi partial x partial y minus partial squared phi partial y partial x. So this is what we have. Now from calculus, you know that partial squared f partial x partial y is the same as partial squared f partial y partial x, and similarly partial squared f partial y partial z will be partial squared f partial z partial y. So therefore, these and these are the same, these and these are the same, these and these are the same. So this bracket is 0, this will be 0, this another will be 0, i.e. the curl of gradient of phi So it'll be 0I. Now minus this isn't just plus 0j, and then plus 0k. For these brackets, all of them are 0. And this is nothing but a 0 vector, which is the result that we wanted to prove. So thank you.